It's Conan Horrors here, and it's time for another update. Based on your comments from the last video, I will be breaking this one up into two parts. First, I will talk about the high-level design choices, and then I'll talk a little bit about specifics on my map generation. Over the last 2 weeks, I have worked on pathfinding. Pathfinding is simply the logic of finding the shortest path between 2 points while avoiding obstacles. I have been working on this because I need to be able to move our character around, and I need to have monsters to be able to figure out how to get from where they are to where the player is. As you can see on the screen, I have floor, wall, and trap squares, and the path is indicated using the yellow dots. As I choose different locations on this map, you can see that the path generally tries to avoid the traps unless it is more efficient to go around than to just go through. This makes the algorithm seem a lot smarter than it really is. Obviously it will always avoid walls, but sometimes it just makes sense to go through a trap rather than around if it's faster and it just costs less altogether. Unfortunately, I've run into a serious problem. The logic that I'm using is called the A-star algorithm, and it's a little slow. When I tested this map with 100 by 100 squares and selected a point, the computer paused for nearly 2 minutes while it tried to find the best path. I have done some work to make this more efficient, but it doesn't really seem to help that much. There are a few solutions I can try. Number one, I can try and limit the number of squares that the computer searches through by limiting its search space to only a 6-square radius. The problem with this solution is that the player will want to click on spaces outside the radius. Any monsters using that radius will also appear to be very stupid. Number two, I can use spaced out nodes with each node having a radius of squares it can access. If I did this, the map would be divided up into sectors, with each sector being 11 by 11 squares, and a node right in the center. When something wants to move around the map, it would go toward the closest node, then follow the node links to the node closest to its target, then search the squares around that node for the target location. The big problem with this solution is that everything would go in a strange direction when getting onto and off of near, nodes. In addition, nodes can't exist inside walls or even between rooms, which would cause anything following node connections to go through walls and voids. Number three, I can use a breadth-first search algorithm. I won't really explain what that means in this video, but the problem with breadth-first searches is that they are not guaranteed to find any path, and they can take longer than A-star depending on the complexity of the terrain. Since I'm using randomly generated levels, I'd say that my terrain is fairly complex. Number four, I can use what is called raycasting. It's not seen as the best or most elegant solution, but it's one that I'm entertaining. This is where a monster goes toward the player in a straight line as long as it has a line of sight. This is obviously a very simple solution that doesn't help the player very much. After all, the hero can't always see the place the player clicked on the map. Monsters would walk directly over traps unless there was some sort of simple avoidance logic. Okay, I've explored a few options, and I think I'm ready to make a choice. What I'll do is only allow the player to control the hero with the keyboard. This eliminates any need for pathfinding when the player wants to move. This means that when a player selects a square way outside of any reasonable small radius, the computer won't freeze for minutes on end while it tries to find the path. For the monsters, I will have them using the raycasting option. To help the monsters avoid traps, I will give them a limited A-star search radius. This will help them to avoid most, but not all, traps. This may not be the best option, but it fits the needs of the game pretty well, and that's all I need. Now, if there were some better ideas that you had that you think I should consider, please put them in the comments below, and I'll be sure to take a look. Anyway, on to talking about level generation. Alright, well here is a JavaScript level editor, level maker. So I can just hit the restart button and you'll be able to see what I've got here, this little blue square that's going around, going in every odd direction. That's called an artery crawler. And these are all called crawlers, but this is the artery crawler, and its job is to go around randomly, laying out hallways until the map has reached a critical size. When it has reached that critical size, then it's allowed to terminate. We have green crawlers that produce hallways. They're not the main vein, artery crawler. They can go around, and when they hit, another floor, one of these light squares, then they terminate. And they can also terminate randomly, as you can see here and here. But they are allowed to make extra connections to rooms and whatnot. Then, of course, we have our yellow crawlers that make the rooms. So there's just 3 types of crawler, and they go around doing their various things. And this is using a concept called complex cellular automata. Each crawler just follows a very, very simple set of rules. So the room crawler, what it does is goes around outlining this room. When it reaches a predefined edge, like it did here, then it turns left. If it hits a wall, like it did here, it turns left. And then it hit a wall again, turned left. It ran into a floor that it had already created. If it runs into a floor that another crawler created, it'll just keep going. But if it runs into a floor that it created, it will turn left. And it will keep turning left again and again, and spiraling inward until it can't do anything else, until it can't move forward anymore. At that point, it then goes in reverse and tries to put walls all around the room, and randomly will create hall crawlers as well. So this is a very early design of my level generation algorithm that I'm going to be using. And this is what is going to be happening every time the player goes to a new dungeon. Whenever they enter the dungeon, whatever that is, then it will generate this way. If the player's already visited a dungeon, then it will be saved obviously into memory and just pull that memory out. It won't regenerate every single time. So, for example, when it creates this, it might say put the entrance to this dungeon all the way down here at the bottom right, and then put the exit over here in this room that's being generated now, or that just finished being generated. And then the player would have to navigate through all of this, the corridors and rooms, and then get there and go down the stairs. Each of these rooms will have opportunities to have water on the floor. It might have chests and treasures. There's going to be monsters. But as you can see, these levels are pretty sprawling. They are large, and that's the idea. I want large level. Oh, this has a lot of room crawlers, which is unfortunate because they were all grouped together, which means that they ended up morphing into big rooms that were just monstrosities rather than really well clear-cut rooms. Anyway, this is not going to be seen by the player. If we go into the code and say while crawler's length is greater than 0, and we need a t in there for length, then just keep updating, and then finally draw once there's no more crawlers. So I can hit the restart button, and boom, there's our level. And go again, boom. So this is how quickly it can generate the layout of the level. What I'm going to be doing next with this is putting in our treasures and our chests, our doorways, etc. And I think I might do that using using some sort of diffusive algorithm. What that means is, I would put, for example, an entity here that would walk around, and when it meets another entity that starts over here maybe and starts walking around, when they meet, then they both die and generate a treasure. This way the treasures are always in locations that are easy to get to. Though that does have a bit of a problem in that we can have, if all the treasures are easy to get to, that can get annoying. Another thing that is really giving me a lot of trouble is up here. You can see all these hallways and all these rooms that are created by the proximity of all these hallways. And so we just have what is essentially this huge room with just a bunch of walls in it. So that's a little bit annoying, but I think I can work through that problem. Anyway, most of these levels have a very good and very nice layout to them. I mean, this is a very viable level. It's a bit on the smaller side, but for most roguelike games, I think this is actually a pretty respectable sized level. But this is more the size of level that I'd be using or be expecting in my game, in the Runes game, because I just want to be able to crawl around sometimes. Maybe some people just want to explore the dungeons, and so I'm giving them the opportunity to do that with these huge sprawling levels. Anyway, I want to continue working on all this, and I'll see you again with the next update. Until then, I'm Conan Horus. Have fun.